Hello, welcome to my channel. Now in this video, we want to find the antiderivative of this function, and of this one, then we compare the two results. Okay, so this is the day 18th of a 30 integrals in 30 days, alright? And in our previous video, I told you that from 21st, the day 21st, alright, to 25th, I'll be solving some integral questions here, and that's going to come from you. So what you have to do is to put your integral question in the comment section, all right? And I'm going to choose the best 5 to solve from 21st to 25th. Those 5 days, all right, the questions will be coming from you. Okay, great. So let's look at this real quick. So I'm going to start with this one, then later on we go on with this one. So you notice this. Well, here I'm going to start with a u sub because I notice something that makes me want to start with a u sub, and you would see. So let's start by saying let u, right, be x squared. That is, we replace the domain of the function with x squared, because it's always a lot more difficult to treat or to change or maybe alter the domain of some function like this. All right, but if we have something outside here, we can easily do some work on that, and you are going to see. Okay, if we make u to be x squared, that means that du will be 2x dx. All right, we can put the dx over here. Okay, great. So you notice that to have du, we need to have 2x dx, all right? So we have x here, and we have dx here, and we have x here. The only thing remaining is for us to have a 2. So instead of, so what we can do here is to multiply this by 2, all right? In that manner, we can just put du in place of 2x dx, right? But then, we have changed the original function, so we need to divide that 2 that we multiplied. All right, and that's what we call multiplication by 1. So that means that the integral will become, put the 1/2, then the integral of 2x dx is du. All right, so that means I'm going to replace that with du. Very nice. And then we have the cosine of x squared. X squared is said to be u. All right. Okay, great. So this is very simple. 1/2 times. Well, the antiderivative of the cosine of u is positive sine u, all right? So we have positive sine of u. And then, since we are done, we can add an arbitrary constant, all right? Okay, great. But then what is u? I don't just want to put down u because u is said to be x squared. So we need to make sure we replace everything with the original variable. And this right here is the antiderivative of this function right here, given that this 2/2 will be 1, right? Okay, that's nice. All right. Okay, so let's go over and integrate this and compare the results real quick. So we look at this. Which method should we make use of? Should we start with the u sub? Well, if we say let u be x, du will be a constant, and here we are just having x squared. No, that's not nice. Okay, let's say let u be x squared, du will be 2x. Can we really alter this cosine of x? Well, I don't know. But I'm not going to do that, all right? We are going to use integration by part. All right, great. So I'm going to start this way with the di method, all right? So we put signs as usual, plus, minus, and as I said earlier, we can alternate these signs as much as we want. Okay, great. So here we have to choose a function to differentiate. This stands for differentiate, this stands for integrate. So between x squared and cosine of x, which one should we differentiate? Well, we should differentiate x squared and integrate the trigonometric function. The reason is, if we take the derivative of x squared to be x, if we differentiate that again to become a constant, right? Sorry, the derivative of x squared is 2x, but I'm really caring about the function part in this case. And if you continue, the thing will reduce in power till it becomes a constant, and after that 0. While the cosine, if you differentiate, it doesn't reduce. So we want to go ahead and differentiate the polynomial function, right? So let me just put the dx over here, I put the x squared over here, which simply means that here will just be cosine of x. Okay, so we differentiate that. That means we're going to have 2x. We take the antiderivative, or the integral of cosine of x is going to be positive sine of x, right? And we go ahead to differentiate again. So you don't just stop after the second one, given that this is not yet a constant. So when we differentiate 2x again, we're going to have, when we differentiate 2x, we're going to have just 2, right? Here we have a constant, so that's where we have to stop, right? And we go ahead and integrate sine of x. Well, the derivative will just be, the antiderivative will just be negative cosine of x. Okay, so had it been this wasn't a constant term, right, we would keep on and we will keep on alternating these signs. But since we've stopped, this is what we are going to do. We are going to multiply this diagonally, this times that, and then we are going to integrate the product of the last row, right, keeping in mind to make use of these signs as well. So this means we are going to have, this to become, well, we multiply this with that will be x squared times the sine of x, right? Then we multiply -2, taking note of this negative sign, -2x times negative cosine of x, that will be positive 2x cosine x, okay? And lastly, remember, we are going to multiply this last row and then we will integrate it, right? So we integrate the product of this last row, that will be 2 times negative cosine of x, that will be -2 times the integral of the cosine of x dx. So from here, right, I'm going to equate the two. So you notice x squared sine x plus 2x cos x, right? And then minus 2 times, well, the integral of cosine of x is positive sine x, right? And then we can put the plus c here. I think this is a nice place to stop. Well, I don't want to factor a lot of things. This is nice, right? So this is the antiderivative of this function, and this one is the antiderivative of this function. This looks easier. So be careful whether this is a smaller power and this is the bigger power and the difference is by 1, or whether it is this way. Okay, thanks for watching, and please do want to subscribe to my channel.